Okay, so it's time for the man in the mirror. Okay, so yesterday we started talking about geometric optics, which is ray optics. And what we're going to talk about first is a plane mirror. So this is a mirror that you like just see in your bathroom, right? Like you walk in, go to brush your teeth in the morning, and there you are in the mystical virtual land behind the mirror. So here's you. Naturally, you wear the fanciest of top hats. But the mirror is right here. Now, if you're looking at this mirror, there's a few things that are kind of interesting about it. The first thing, and I'd like you to go do this right now. I'd like you to go into your bathroom and does your actual image in the mirror change size whenever you get closer to the mirror and farther away from the mirror? So go try that right now. So regardless of if you are close to the mirror, far from the mirror, you should see the same amount of your face the whole time. It might look like you're closer to the mirror because your virtual image is getting closer with you, but you'll only see what you see. You're never gonna all of a sudden move far away from the mirror and all of a sudden magically see your feet if you could only ever see your head. So that's something to think about. Yeah, Gio. So we can actually prove this by doing the following. So here's your eyeball. It's this purple thing right here because, I don't know, you have purple eyes. And let's actually bounce rays off of this mirror. So we've got our man in the mirror here. And here's your purple eye that I was talking about. And let's just bounce rays off of things like our hat or our foot off the mirror and then hit our eye. So if we bounce a ray off, so some light hits our hat and then this hat strikes the mirror. And you know what, this is going to be a little bit pain in the butt, but we can do this. The light ray is going to strike the mirror, and that angle of incidence has to equal the angle of reflection, so when it comes out, it hits your eye. Okay? And that's because, this is perfectly normal, and those two angles, which are very tiny, are the exact same. If we do the same thing with your foot, we don't actually, bounce it like this. That doesn't make any sense. The angle of incidence and reflection have to be the same. So when we do this, we're actually going to bounce right about here, because then our angle of incidence and our angle of reflection will be the same, and you actually hit your foot. So there's our angle of incidence, angle of reflection, and we see the foot there. What this actually means is that in order to see your entire body, you only need this much of the mirror, which if we actually measured this and boiled it down, you only need half of your body height in order to see your full mirror. So Nate, you were talking about how you have a full body mirror so you can see how you look. You don't need a mirror that big. You only need a mirror half the size from the very tip of you to the very bottom of you to see the entire body. And we see from this that it doesn't matter if we are close or far from the mirror because these are angles that are causing this. And no matter what happens, the angles are not affected by any distance. So that's what we see with kind of man in the mirror. And if we kind of scroll down, if we projected these back, we'll actually see our image. So what we see here is that if this light comes in, hits the mirror and bounces into your eyes, and this is the half length of the body you need, what you actually see in the mirror is the backtracking of it. So you actually see this on the back end, and this this is where your eyes think the image is coming from, but it's not really there, right? There's no light on this back side here. The light bounced off the mirror. This is all in darkness, right? It's like the dark night. But this is where your eyes think the light is coming from because your eyes don't understand how light bounces. Your eyes think that the light has to travel in a straight line, so your eyes go, yeah, this is a straight line right here. There's a man in the mirror. Just like that. Okay? So that's actually what you're seeing with a plane mirror. That's what's going on, and it doesn't get any more complicated than that. So if you're far away, if you're close, if you're in the middle, it doesn't matter where you're at, you're always going to see the same amount of your body for something like a plane mirror. As long as that mirror is perfectly flat, you'll always see your whatever you saw to begin with, depending on the size of the mirror. And as long as you're closer, we know when we backtrack this, our person will seem closer on the other side. So we'll have a very similar shape like that. Okay? So that's what's going on with a plane mirror, what we kind of see from it with our man in the mirror. But what we're going to take a look at next is what happens when you don't have a plane mirror. What happens when your mirror is curved? Ooh. And things are going to get really interesting. But until next time, adios and take it easy.